and artificial intelligence, automation and robotics, virtual and augmented reality, digital twin and blockchain technology. Introduction. The construction industry is undergoing a digital transformation with the emergence of new technologies. Can you see the screen? Am I standing away?
Over there.
Okay.
I'll show there. Easy for you. So you can see the screen.
Thank you. Right, okay. So, with the emergence of new technologies that are changing the way we design, build, operate buildings, the fourth industrial revolution has brought about a wave of innovation and in the construction sector, enabling us to leverage the power of data, automation and artificial intelligence to drive efficiency and productivity. 3D printing, one of the most exciting developments in digital construction is, of course, 3D printing. This technology allows us to create complex building components quickly and efficiently, reducing waste and cost and improving accuracy and precision. Building information modelling is a powerful tool that enables us to create digital presentations as buildings, allowing us to visualise designs and identify potential problems before construction even begins. With the integration of artificial intelligence, BIM can analyse vast amounts of data to optimise building performance and reduce energy consumption. Artificial intelligence powered BIM can also help with scheduling and logistics, enabling us to streamline the construction process and reduce delays and cost overruns. Automation and robotics are changing the way we build, allowing us to automate repetitive tasks and improve safety on construction sites. Robots can perform tasks like bricklaying and welding with greater speed and accuracy than humans, reducing labour costs and improving efficiency. In addition to physical robots, software automation is also becoming more prevalent in digital construction. Automated workflows and processes can help teams collaborate more effectively and reduce errors in rework. Virtual and augmented reality are transforming the way we design and visualise buildings. With virtual reality and augmented reality, designers and clients can immerse themselves in a virtual environment, allowing them to experience the building before it's even built. Augmented reality can also be used on construction sites to overlay digital information onto the real world, helping workers visualise plans and identify potential issues. Digital twin technology enables us to create a digital replica of a building, allowing us to monitor its performance and make adjustments in real time. This can help optimise energy consumption, reduce maintenance costs and improve overall building performance. Blockchain technology can be used in digital construction to improve transparency and collaboration by creating a decentralised ledger of all project data. Stakeholders can access information in real time and ensure that everyone is working from the same set of data. I'm going to pause it there because thank you for your attention, but this is not my presentation. This wasn't created by a human being. This was created by AI in 6 seconds. I was able to go to a website, find artificial intelligence software. I got an app, a 2Me app. I was able to set up an account using my Google login. I was able to basically tell it what I wanted with some user prompts. And like I say, I was flabbergasted that it was able to generate the text that you've just listened to in 3 seconds. It was then able to render the photographs and put them into that presentation in a further 3 seconds. The whole thing was done in 6 seconds. Let that sink in. 6 seconds. If any of us wanted to do that, we're talking half an hour, 2 hours, whatever it is. We couldn't do it in 6 seconds. We couldn't turn the computer on in 6 seconds. So I'm sorry for that little bit of subterfuge there, but I hope you enjoyed it. And what we can actually do now is we can actually start my presentation. Enjoy that?
That was good.
Right, so I hope that's got your attention. I hope that got your attention online as well. But we are really looking at the future now with emerging digital technologies. So without further ado, I'm going to carry on and get started with my first set of slides. So emerging technology, what is it? So commonly it's used to describe new technology, new digital technology on the market. It also refers to existing tech that's continuously being developed. So what are the topics we're going to cover on here? So these are the different technologies that we're going to cover. I'm not going to read them all, but I'm going to allow you to digest what you're going to see there. And where I'm going to start and where we need to start is what is Industry 4.0? What's the fourth industrial revolution? Right in the centre, Industry 4.0. Let's give a talk about that. So, Industry 4.0, fine. In order to tell you what Industry 4.0 is, or the fourth industrial revolution, I need to start at the beginning. So, in the 1840s, the first industrial revolution happened in England, and it progressed to spread across Europe. The first industrial revolution was effectively mechanisation. It was machinery. It harnessed water power and steam power, and it changed the world, leading up to the second industrial revolution. Now, this is what brought mass production. So you can see the picture, if you can see the picture, it's a Model T Ford production line. This brought mass production, assembly lines, and also power for these lines in the form of electricity for the first time. The third industrial revolution was the advent of the computer age and automation. And what that led to was... It needs to be that. Can I do that? Can somebody do that online? Thank you. Brilliant. Okay. So computer age and automation. So you can see in the picture there, we've got cars again. Cars being built by robots. And that leads us nicely and roundly onto the fourth industrial revolution. What is it? It just says there's cyber physical systems, and you can see there's a human being there with a little joypad, and then there's some drones and humanoid robots and walking drones. That isn't enough. Let's get on with the presentation, and we can learn more about exactly what the fourth industrial revolution is all about. So, I haven't got time to go through all of this, but what I will draw your attention to is this is something that was produced in a peer-reviewed science paper, and it describes the pre-industrial society, the industrial society, and what happened in the first industrial revolution, and then it describes the post-industrial revolution. If you see the coloured blocks that I've put over the top of them, that's the breakdown of what we have. So in this industry 0.0, or before the first industrial revolution, is in pink, and then we've got the industrial revolution, industry 1.0, and then the next being the post-industrial societies. Because this is quite well merged together, I couldn't break that down, so I had to merge the post-industrial society for the second and the third industrial revolutions. Now, in the blocks here, you'll see that it's divided up into, across the rows, technological transformation, economic transformation, and social transformation. So the key thing I'm going to point out here is the leading sector at the time. As I say, I haven't got time to go through everything. We'll be here all day. But the leading sector at the time in the pre-industrial society was agriculture. Yeah. So agriculture was the big thing. Everybody was into agriculture. At the turn of, or the advent of the first industrial revolution, that changed. So the leading sector globally became industry and manufacture. And then for the post-industrial society, after the next phases of the industrial revolutions, we went to the service industries. service sector, and that included services and comfort goods, we effectively achieved for the first time mass-produced luxury items. Okay, so what I wanted to do is a little experiment, and this is what I did this was in my dissertation as well, is I continued this chart across to include what I call the future industrial society. And you can see here that these topics are kind of carried across. If you look at the key social groups at the bottom in the social transformations, in the pre-industrial society, the key social group was peasants, because we weren't all kings and chiefs. So of course we have to be in a label, and then we were peasants. In the Industrial Revolution, peasants became manual workers. In the post-industrial society, manual workers became office workers and service professionals. So who's that? Who's the key social group in the fourth industrial revolution? I think it's everyone. Okay, so let's get on with the rest of the slides. Right, technology. So 3D printing. So the AI told you a little bit about it at the beginning. I'm just going to talk about what we have here. So there's many types of 3D printing, but we're going to concentrate on extruding, which is effectively where a nozzle will hover around and deposit a continuous flow of material, cementitious material in most cases, and slowly build up in layers a structure. So you can see on the top left-hand side, that's a bridge made out of metal that was extruded. It was a 3D printed bridge, and it's currently in use in Amsterdam, crossing a canal. If you look at the top right-hand side, you can see a couple of houses that are under construction, and that's pretty standard. That's what they look like. If you look at the bottom left-hand side, what you'll see is a multi-storey 3D printed structure with people working on there. What you can't see here is the nozzles. I'm sure there's plenty of examples for you to see extruding and going on. On the bottom right-hand side there is a finished 3D printed house with a swimming pool with some water in it. That is, in a nutshell, that's pretty much what we're looking at. What the thing that I want to give you attention or draw your attention to on this is there's straight lines, but there's not angular changes in those lines. What you're seeing is curves, and that technology, the 3D printing technology, takes full advantage of that. It's easier to swing around a curve with an extruding nozzle than it is to do a hard 90 degree. So that's why it's predominantly got lots of curves in it, and the designers, the architects, take full advantage of that. Okay, BIM. Some of you have heard of BIM. Most of you have heard of BIM, but there's a lot of misconceptions around BIM. Now, I'm not going to drill down into what BIM is. I'm just going to try and elude some of the misconceptions around BIM. So, building information modelling is also known as building information management. Now, when I started my master's degree, this was the very first lesson I got, is to determine the difference between the two. So, if you take the main title, the top title there, building information modelling, that will refer to the BIM dimensions. If you look at the second title, building information management, that will refer to the BIM levels of development. So, if I start with the building information modelling side of things, we've got the BIM dimensions 1D, 2D, 3D, 4D, 5D and 6D. I'm going to ignore 1D and 2D because there's lots of discussions about what that actually means, and start with 3D. BIM 3D, or 3D BIM, is effectively the three-dimensional virtual model. 4D BIM is inclusion of time, so it's the model being able to actually move. 5D BIM is taking that one step further and adding cost elements to the data, and going forward from that, when we go to an operational building in digital twin, which we'll discuss later, 6D is the performance of that building, it's the energy efficiencies, it's the occupational habits of the occupants, and that's all picked up through sensors, which again we'll talk about later. When we go to the building information management system, or the BIM levels of development, it's about when we have BIM level 0 is no collaboration. It's where we were about 25 plus years ago, where we had everything was on paper. We barely had phones, mobile phones. It was a mess. Level 1 was partial collaboration. This is where we were able to start sharing turn-based. We would send architects the design brief. They would produce the build drawings that would then come to site. Site would then produce the product and then generate as-builds, which would then return back to the architect, which would then put the file together, which would then go to the client. Right, so interesting. But where we've been recently is BIM level 2, and that's where across the UK adoption's at the moment, and this is full collaboration. We've definitely got BIM level 2 at HPC. It's a common data environment. It's universal communications between softwares, like the IFC files, for example. And then level 3, which is what HPC kind of moves on to, is moving towards IBIM, or full integration. I'm going to move on for time, but I think that dispels some of that myth. This is a great chart, a nice graphic. It shows us where we are and incorporates things. I'm not going to go and talk through everything, but what I do want you to draw your attention to is the red line between BIM level 2 and BIM level 3. That's approximately where we are in the industry right now. When you get the slide packs, or if you're watching on the video, please pause and explore this. Mobile devices. That's an emergent digital technology. I'm not going to tell you what they are because it's going to be a bit insulting. I'm just going to say tough pads and mobile phones. And that brings us nicely on to, comes up, construction software. So we've got these mobile devices and we can import construction software onto them. What's construction software could we talk about? We could talk about importing something like Tekla, to get models up and 2D drawings up. We can use it to open up the program data. We can look at the works information. We can use it for ordering concrete. We can use it for all sorts of things. There's all sorts of software that's available on the tablets and on your phone through applications. Right, virtual reality. I will be surprised in here if nobody's heard of virtual reality. Virtual reality has been around since the 80s. It's pretty advanced now compared to where we were a long time ago. But I'm going to define what virtual reality is so as we can dispel any myths about what things are. Virtual reality is effectively you as a real person temporarily entering the virtual environment, the virtual world. So on the opposite end of that scale, we have augmented reality. Now you can see there, that's the Doka FrameX that we had a demonstration on a few years ago. And what that was the ability to use a tablet or a phone and use their app to look at their drawing, and it would create on the screen a 3D interactive model in front of you. But you could only view it through the device, through the tablet. So where we need to start looking at this is the reality virtuality continuum. So one's on the real environment, so that's VR entering the real environment, the real world, and at the other side it's the real world entering virtual reality. Kind of good, but we can do better, and we are doing better. We need something in the middle, something that's going to enable us to walk around with that interactive headset and extract and see the real world behind it. What we need is something kind of in the middle. So we need to be able to walk around within a construction site and be able to visualize the design in real time as we're wandering around and see how things work. Okay. There's a name for this, and you're going to hear this probably for the first time, some of you. It's not AR, it's not VR, it's MR, mixed reality. Okay? So for some of you, that'll be the first time you've heard that technology. When you're seeing people walking around with goggles on site, they're not using VR headsets, they're not using augmented reality, they're using mixed reality. Okay, moving on then, automation. I probably don't need to tell you what automation are. Robots in manufacturing have been around for a long time. What they are good at is doing heavy, repetitive tasks very, very quickly. Right, so there's a method in my madness. I'm going at the sensors now. So we know thermocouples in the middle. In the middle there, we've got thermocouples. Put it in the concrete. It's effectively a temperature gauge that's recording differential temperatures over time. Yeah. So we know the date and the time at which it was a certain temperature, and you can see a curve appearing on a graph. Right. So we have other types of sensors. We have light sensors. Light sensors determine when it's dark outside, that will then automatically turn on the lights. There's anemometers that will determine the speed of the wind outside. There's all sorts of things. And in that building, you can see some of those sensors. You've got bin sensors. What the bin sensor will do is work out, detect the weight of the trash, and it'll work out the volume of the trash, and then try and figure out best way to do it is to communicate with the utility services, the bin men, and let them know when they can come and empty the trash. But how are they going to communicate? This is the point. Through the Internet of Things. So all these connected devices, these scanners, sensors, they're all wanting to give their data away, and we need to get that somewhere. Where we're going to get that is the IoT, Internet of Things. So they'll communicate onto a network, and they're ready to share that information to a central repository online. Any data, it's absolutely everything. And we're talking big data. All these sensors are going to be reporting their bit of information to everything. Now, what the Internet of Things in the construction industry could do, we could do site monitoring, we could do machine control, we can do construction safety, fleet management, and project management. Now, I'm not going to labour the subject too much here because we've got a lot to cover, but this is a real emerging technology that's really going to take off. Okay, who's heard of blockchain? You've all heard of blockchain. Okay, what is blockchain? Blockchain is effectively a store of value. It's information that is available in a public or private repository or ledger. And what's good about it is once it's input onto the blockchain, data on that blockchain cannot be changed. So security is incredibly high. So the benefits of blockchain is we can have something called smart contracts. Smart contracts will enable us to build trust, reduce costs, and accelerate transactions. What do I mean by accelerate transactions? Well, at the moment, you'll do a measure of works, you'll put an application in, you'll be lucky if you get your payment in 60 days. What smart contracts will enable us to do is we'll able to have tokenized points along the smart contract, where as each stage is completed, payment can be instantaneously released as soon as sign-off happens. That will reduce costs. Why will it reduce costs? Right, okay. One of the things in the construction industry at the moment is that lots of the costs are handled via finance, and finance is handled by a factory and they're effectively borrowing money. So if a company is borrowing money at 6, 10, 20% on top of what they're borrowing over time, we can reduce that need for borrow because we can pay them instantaneously, because they'll effectively be waiting for payment. So if we can pay them quicker at every stage, i.e. when they've bought the materials, when they've assembled the product, once they've shipped it, it's arrived at site, and once we've installed it, everybody can be paid at key stages. So they don't have to borrow money for so long and pay interest on it. That's the big thing. With the security built into the smart contract, we can build trust. Okay. Automated design. Right. I don't know if any of you have heard of automated design, but it's effectively, now, please don't confuse this with artificial intelligence. It's not. It's automating the design of things using algorithms. The difference between in artificial intelligence and automated design is one is raw crunching, following algorithms, and artificial intelligence is creative, and we'll get onto that soon. So what I'm going to show you here is this is an optimizational piece of software. So what you'll see here is there's effectively 5 apartments, yeah, and it looks like it's possibly on the ground floor of an apartment building. And the computer is going to work out CO2 efficiency on a range of configurations. Now, I'm going to tell you how many. It's going to work out the optimized layout of rooms on 3,300 different designs. Watch the video and you'll see how fast it does it. Okay. It's going to play. Speak to the apartment, please. Right. You operate selecting the 5 apartments, selecting CO2, selecting it during the daytime, run. Finished. 3,300 configurations that it generated and then analysed. I think we'll watch this a couple of times. Look at it. Now, if that was a person sat there trying to analyse 3,300 different configurations, what are we talking? 2 weeks? A month? 2 months? I don't know. But you've just watched the computer do it in 10 seconds. That's emergent digital technology. That's automated design for you. That's the incredible number crunching that these machines can do if programmed correctly. Okay. Right. Just not going to start. Stop. Right, okay. So the real exciting part one now is, why won't it move?
Page down.
I've tried page down, it just wants to mess around with a drawing, with a movie. Right. This is something that's going to absolutely blow your mind. Now, let me do a little bit of cheat in a second.
AI image creation is no
Bear with
longer
me.
just a gimmick.
Can you hear that video online, by the way? Did you hear that?
Yeah, that's clear enough, Scott.
Thank you. Thank you. Okay, right. So let me just talk about what you're going to see. So this is a house, kitchen, it's indoors, it's a 3D model in Revit. Now we want to create a photorealistic image here, okay? Now, there's different softwares out there that can do this, but they're using you to sit and click and work out things. Now, what a photorealistic image is something that incorporates light, hotspots on light, shadow, and things in perspective. Okay, please listen to this guy that's about to start talking, who's going to talk you through what's going on now. He's going to use the word parentheses several times. What he means is that's the American version of what we call brackets. Okay, so just bear that in mind. And with that, enjoy this.
For this example, I'm actually going to use an interior scene. This is the modern kitchen. Those of you guys who have followed along the channel probably have seen this before. And we're going to launch a bold lab. Now, I figured this would be a cool example to show you some interior stuff as well. So Notice I'm just going to again try and match it as best I can. I'm going to check the box that says is interior. And now for the prompt, I'm going to use modern kitchen, white walls, white ceiling, white concrete floor, forest outside seen through the large glass windows. Now you can see it's doing something.
Done it. It did it already.
And now if I want to say, I want to stress some things a little more. So I'm going to add, in parentheses, I'm going to say green furniture.
Okay, so now he's changing
Parentheses, I might click render.
the image. This is the
See what it did is
photorealistic
it made
image.
all
He's done it
the
already.
furniture
He clicked the button and it was
Now
done
let's remove those
instantaneously.
parentheses.
He's going to change it
I'm gonna
again.
have the same prompt, except what I'm going to do is I'm going to say dark wooden cabinets. Click render.
Click the button
So now you can see
instantly,
it's
less
using
than
the
a
green furniture, but
second.
now it's stressing the dark green cabinet. So there you have it. The 3 tips you can take away from this: using model
So,
elements and materials.
I'm going to let
guide
you watch
a
that
robot.
again.
More examples. I'm actually going to use an interior scene. This is the.
Now you know what you're looking
those
at.
of you guys who have followed along the
Enjoy
channel
what
probably
you're
seen this
seeing. Now
before.
you know.
And we're going to launch it both lab. Now I figured this would be a cool example to show you some
So he's going
interior
to
stuff as well. So
change
notice
some
I'm just going to
settings
again
and
try and
type
match
in
it as
here
best I
the
can.
prompt.
I'm going to check
So
the box that
prompts
says
will
is
allow the
interior.
AI to
Now for the
start
prompt,
being
I'm going to use modern
creative.
kitchen, white walls, white ceiling, white concrete floor, forest outside seen through the large glass windows. Now you can see it's doing something.
He clicked and it was done
and now if I
instantly.
want to say, I want to stress some things a
Pretty
little
nice
more. So
kitchen.
I'm going
I'd
to
want to buy
add,
that. I wouldn't buy this one
in parentheses, I'm going to
off
say
plan, but I
green
might buy that one off plan.
furniture. In parentheses, I'm going to click render.
Okay, so he's
Now you
changing
can
it
see
again.
what it did is it made
Clicked
all
it
the
instantly.
furniture
It's
green.
changing.
And now let's remove those parentheses.
And he's going to do it
I'm going to have
again.
the same prompt, except what I'm going to do is I'm going to say dark wooden cabinets. Click render.
Watch how long it
There you
takes
go.
when he clicks it.
So now you can see it's using the green furniture,
Instant.
but now it's stressing the
Okay.
dark green cabinets.
Thank you so much
there
for
you have
watching
it.
that video.
3
That's
tips you can take away from we pulled
the-
together when we're designing a project.
sorry.
But now
right. So you understand there's no way I could describe that to you without showing it to you, both automated design and artificial intelligence. But there's also more to learn. And we'll move on to them now if I can get it to move on. It doesn't like moving on.
imagine being able to.
Okay, terrestrial scanning. Right. So we've seen these 3D scanners around site. It's an iron bridge as well, yeah.
That is Iron Bridge.
Oh, that is iron bridge. You would know, you're expert on bridges, Mike. Right. Okay. So let me just talk about the technology. Terrestrial scanning. Right. What is it? Okay. So we are using the scanners to create a point cloud. What's a point cloud? It's lots of points. What's a point? A point is a known place in space in a virtual world. How does this 3D scanner do it? Right, okay. The 3D scanner, as you can see in the top left-hand side, on the top left picture, is a machine like a theodolite, kind of like a total station, but it's a scanner. You can't really use it for setting out. And what it does is it knows exactly in 3-dimensional space exactly where it is to the millimetre. It also knows its orientation to grid north. With that knowledge, what it can do is generate a whole circle bearing. Okay, so it will know which way it's pointing. Inside there, it's got another dial which handles the vertical plane. So it'll handle the vertical angle of which way it's looking. So it knows where it is left and right, and it knows which way it's pointing up and down. That's the vector. That's the vector from origin to point. Okay, so it's going to shoot out a laser, LiDAR, or radar to the point. Okay. Now, how that does it is it sends the light out as a pulse, and it starts a super accurate clock. And then when the beam, the pulse hits something, some of that energy is returned back to the device. And when it receives that return signal, it stops the clock. And it's milliseconds. Very fast. So, how does it do it? Well, that pulse is travelling at the speed of light. Speed of light is a known constant. And you've heard the expressions time over distance. Well, if we invert that, we can use... Sorry. I've lost my prompt, but it's effectively time over distance, so it's a bit nervous, sorry.
You can't find a distance, aren't you?
Yeah. Time over speed. Yeah, you got it. You've got it. So we know how long it took. We know the constant speed of light. And what we're going to do is, because it went there and back, we're going to halve that time. So with the vector of knowing the origin, knowing where the target is, and the distance to it, we can create a point in space, a singular point in space. Now, if we repeat that more than once, 10 times, 100 times, 1,000 times, 100,000 times, million times, and at times billions of times, we can create many, many points. That's the point cloud. That's what you're seeing on the right-hand side there. Now, that on its own will create shadows. So what they normally do is they just move the device 10 metres to the left, 10 metres to the right, shoot again, repeat the performance, and that will find more data. And they do that again and again and again until they've picked up as much data as they physically can. And that's basically terrestrial scanning. Have you ever heard of these 3D walking tours or 360-degree virtual tours? You've probably seen these on estate agents' websites. They're really handy. You can go room to room and have a nosy around somebody's house without going there. But the technology, the leading technology is Matterport. And what that does is that you can put this in a room and it will spin around and take pictures all the way around. But not only will it take pictures, it will do a LiDAR depth map to where everything is and then overlay the images that is taken via the camera. And what that enables you to do is very clever, and it stitches all this information together and it creates what we call the dollhouse. That is a terrible picture, I will say. That's a terrible version of dollhouse, but it gives you an idea of what's going on. So it's created this 3D environment with pictures. So you can choose where you go and what you do, and you can wander around that house, and it's great. Now, construction. Let's forget about estate agents. Construction. What good is this in construction? I'll tell you what it is. If you can imagine you want to do a condition survey on an existing building that you're taking over, architecturally, restoration-wise, renovation-wise, you could wander around with Matterport and take a very detailed scan of the conditions. What furniture's in there? What condition the walls are in? Is there any mould, damp, cracks? Anything else can be recorded here to let you know exactly where something is and what condition it is. And that's where it takes over from terrestrial scanning. Terrestrial scanning was able to give you a point cloud that was very, very accurate. This is less accurate, but the terrestrial scanning, the point cloud doesn't identify what it is. So you have to physically go there or take some pictures to figure out what it's picked up. With Matterport 360-degree virtual tours, you can see what it is. You can do an assessment. And if you take that data and you stick it into a central BIM repository, everybody, designers, in the future, people that are going to be doing demolitions there, will know what was in the building at that time. All right, moving on. Drones, everybody's favourite subject. Right, above there you've got an aerial drone. Aerial drones you can fix things to. It can fly around itself or it can be controlled. What it does is it can do photogrammetry, aerial surveys, LiDAR scanning. It can do thermal scanning. So if you're looking for missing people, for example, it can find a heat signature in woodland or something like that. Under whichever parameters it is, it can be used to take aerial photography to record things from a vantage point of above, which is sometimes quite good, especially over large distances. Okay, right, so drones. We all know what drones are. Spot the Dog, Boston Dynamics drone effectively here. It's an autonomous, self-driving, self-correcting, collision-avoiding robot. It's effectively a drone. In this configuration, it's actually got a scanner on its back, so it will wander around inside a building, stop, take a scan, pick itself up again, and then carry on and do it again around the building, giving you a virtual scan on its own, working almost totally autonomously. It does need guiding at the moment because it does make terrible mistakes, but we won't talk about that. Okay, robotics, right. Robotics. Okay, so there's a prototype concept humanoid robot in the top right-hand side. That was used to pick up from stacks boards. So it can pick up from a stack and put onto another stack. It can physically pick it up and walk around with it, and it can put it in position onto a wall, this board, and fix it. So this is where our workforce are terrified, and they should be, basically, because that thing is useless, but its children are going to take a few jobs. On the bottom side of that, you've got assembly overhead gantry robots, and this is putting together a timber frame pod that could be lifted in and installed onto a building. Don't ask me why it's that shape. I've got no idea, unless it's prototyping and it's just challenging its abilities to deliver complex shapes. Behind there, you can see CNC machines that are cutting planks and boards to the correct size and shape accurately, so as then these arms can assemble them. Okay. Right. So you saw the dorky looking prototype humanoid thing. Tesla are developing something a whole lot better. Have a look at this. How's that for impressive? Can't see my presentation.
Do you want to go on page?
Yeah, so what I did is I put cursor down, so I didn't know where it was. It's like, right, digital twin. You've all heard of digital twin. Digital twin's been spoken about for a few years now. But what is it? Okay, so digital twin is a virtual representation of the physical world. And how we use that is we'll have a virtual model which is used at the design stage. That is the start of the digital twin. So that model will be used to inform the construction of the real thing. In this case, it's an oil rig. So we will then use that information from the design model, which is the first iteration of the digital twin, to construct something in the real world. Once we've constructed it, or as we're constructing it, we'll feed back to the model as the as-built model, which will become the final digital twin. So at the design stage, before we construct, digital twin is being formulated. It's almost ready, but we need to finish the real one in order to get our fully realised digital twin based on the as-built. Okay, do you get that concept? Quite simple. Right, so we're going to go now into cyber physical systems. Right, this is going to start tying in some of the stuff. Right, so do you remember earlier on the slides we had the sensors, the building sensors, yeah? We had these sensors that were reporting to the Internet of Things, and the Internet of Things is where the cyber physical system, which is a digital type of digital twin, can analyse what's coming in the way of data. So there's many things it can analyse, and we could go and talk forever and a day about it. But what I'm going to talk to you about is something quite unique. So imagine our buildings in a earthquake high potential area, such as southern India. So we'll have these buildings with these accelerometers all over the foundations, all over the building. Right. So what that's doing is actively monitoring movement in the building. It'll take up and pick up bits of sway and swing and anything else. But in the event of an earthquake or an event, it can start recording, or it will continue to record. And what it will do is it'll let a central repository, a cyber physical system, know that the building was moving at what speed. So the accelerometers will tell the cyber physical system that's recording the data when it started moving, how fast it moved, and how far it moved, and in what direction, and continuously throughout a seismic event. That data is recorded. So when we need to do a quick assessment of a building, now imagine we're in southern India and we've got 3,000 buildings in our city, and we need to do a quick assessment to find out which ones need our immediate attention from our engineers and which don't. The digital twin can be programmed to see what effect those accelerometer readings would have on the digital twin, which could forecast if that building is well within parameters to what it was exposed to, or if it was exposed to something far greater and may need engineers on site to determine if that building is safe, needs to be evacuated, or possibly needs to be controlled demolition to bring it down safely. So that's something that can be done. But in the everyday world, it can monitor how many people are using the building. It can monitor efficiencies, CO2 emissions, or efficiencies rather. It can tell you how many people are in the car park. It can tell you everything. It can tell you if you've got rodents, tell you if your basement's flooded. That's another thing it could do. It could record an event of a flooding in a basement. The sensors could tell you exactly what system failed to operate, because there'll be multiple sensors on multiple machines. And within the machines, i.e. the pumps can tell you what the pump was thinking. So the pump should have been triggered to start, and it never got the signal from a sensor, and you can have that information. What it can also do is if a pump's failing, it can detect that something's gone wrong and report maintenance teams to go there and figure out what's wrong and manually start pumping out basement before you lose and cause thousands, if not £100,000 worth of damage. All right. Hyper-automation. Have you heard of hyper-automation? Anybody online in the room? No? Okay. It's automating the automation. And I could tell you all about it, but there's a little video here that will tell you better what hyper-automation actually is and how it's got the potential to really make a difference in our business and in businesses around the UK and around the world, actually. Okay.
Hyperautomation is a strategic enterprise initiative that can deliver a continuous automation journey with superior business outcomes by leveraging a combination of technologies that complement the adoption of the core, robotic process automation, also known as RPA. Essentially, it's an expansion of automation, where everything that can be automated will be automated. As organizations mature, their automation capabilities move away from automating simple, well-defined tasks to more complex, exception-heavy processes. The need for multidisciplinary governance, audit, security, and process optimization surges. This drives the importance of integrating complementary technologies to the RPA toolset with solutions like process mining, analytics, ingestion engines, and machine learning to create a comprehensive approach to amplify the efficiency and effectiveness of work automation. The key components for hyperautomation include, number one, artificial intelligence capabilities which incorporate machine learning, natural language processing, also known as NLP, intelligent optical character recognition, better known as OCR, and AI computer vision, so robots can read, see, and process more work. Number two, advanced process mining platforms that can look deeply into how your teams work to show you what you can and should automate. Number three, advanced analytics to track, measure, and prove the business outcomes delivered by automation to enable continuous growth. And number four, capabilities to augment the workforce engagement to involve business users, technical users, and subject matter experts across the organization to contribute to hyperautomation. With Gartner naming hyperautomation as the number one trend on their list of top 10 strategic technology trends for 2020, IT and business leaders have made hyperautomation a key strategy to drive their organization's digital transformation. To help unlock the potential of their automation investments, Jolt Advantage Group provides end-to-end solutions to manage the full cycle of automation, including the discovery of automation opportunities, training and empowering business users to become self-sufficient citizen developers, incorporating cognitive technologies to allow people and robots to automate together more complex processes, as well as tracking and measuring the ROI to enable continuous scale of the automation footprint and successfully establish hyperautomation. Contact us today to receive a free assessment of
Okay, so that's basically what hyper-automation is. One of the things that come under that would be, as you saw there at the end, was the human-machine interface. We're not talking about cyborgs and things like that. What we're talking about is using wearable technologies to improve the performance of skilled workers. So let me explain that a little bit to you. What that is, so you can imagine have a semi-skilled worker. So say, for example, he's been used to using an AI-powered headset. He's been using it since he came into the industry. He's got an intelligent system that's managing everything that he's doing and advising him on what to do with a heads-up display showing him what to do. So he is a carpenter. Okay, now, unfortunately, you don't need a carpenter today. You need a diesel fitter because the generator's packed up. Okay, in the future it'll be electric, but I'm just saying. So we need a mechanic. So the guy who's been used to using this AI-driven wearable headset can then go into a completely different environment on a completely different skill set. And the AI on board on his headset can show him what to do and how to do it. And not only that, how to do it correctly, and do all the paperwork and QA associated with it in the background, generate the forms, get them signed off, get it commissioned. So that's an idea of what that can do, but there's so much to hyper-automation. You've heard it here first. It's going to be the future and it's going to be spoken about, I believe, all over the show. Change. Sorry, I'm trying to get the page to turn. Might know about emergent technologies, but I can't use a laptop.
Right. What you need is a headset.
Yeah, I'm not quite finished yet. Okay, so this slide, when you get the slide pack or when you're watching the video, please stop and look at this. This breaks down all the digital tech and systems and blockchain, everything on there. It's a great slide. Okay, so please get a chance to look at that. I'm not going to talk you through it. You can discover yourself. Okay, thank you for listening. Any questions?
Yeah, just for those who've heard my lectures about the glue fixings, we use the LiDAR in the hydrogen tunnel scans, and that's how we found the dropping.
That's right.
Dropping weights. We also use, for the other stuff, I did the underwater survey stuff, we use multi-beam sonar point clouds for underwater structures. Exactly the same. And also, you're on about the building controls and the sensors.
Yeah.
I'm pretty sure there's some buildings in Hong Kong and in Dubai that have mass dampers in them that are controlled by those sensors, and it protects the building against extreme weather events and earthquakes where the building starts to sway.
There's different fluid in the hydraulics.
Yeah.
Depending on what the
you're absolutely right, Mike. That is the technology that it's using. So it's using the accelerometers in the building to detect motion.
Absolutely.
And it's using that to inform the dampers. Instead of just having a big rubber pad, it's actually arming and moving hydraulics around and helping to try and dampen those forces on the building.
It's active, isn't it?
Yeah, active dampening, that's right. Thank you for that. Is there a question to go along with that?
No. I was just going to say that that sort of falls into the other stuff with your digital stuff, is that the building can then be much lighter. It doesn't need to be strong enough to withstand those things.
That's right.
Because you have that active protection.
That's exactly right.
really interested in the first part of this because it's been probably in the news just recently, hasn't it?
Yeah.
Someone can who's doing a degree, put the paper in.
That's right.
Not put the paper in, because they get something else to do. Also,
I'll just remind you, I actually did my work. I didn't use it.
I'm just saying, it's very apt, it's in the news quite a lot, and being spoken about, because some people can do that,
Yeah.
put the question in, the whole paper for their thesis or whatever can be submitted, but also the person marking it can put that in and get it marked automated as well.
That's
They don't even have to mark it. So university students can submit it and the teachers can, the professors.
So there could be substitutes in both angles.
Yeah. I'm studying a degree, I'm in my second year of Christian theology. One of my subjects, I submitted my paper, I had my grade back, and I thought I'll just try it. And I did the same things what we did. And I put in my question about the Council of Nicaea in 325 with Constantine, and it came back non-robotic as well, just like yours was. It's amazing.
It is
Amazing
amazing.
and scary, I think. In the wrong hands, in the right hands it's good, in the wrong hands it's just.
Yeah.
Okay.
The other thing we use the LiDAR point cloud thing is as you go up the A3, on the Hog's Back, there's a turn of the century bridge, which is basically made up of cast iron plates, hot riveted together. And there was not a drawing for that. We were having lots of problems with the bolts falling out and stuff like that. So we scanned it from 5 different positions. And then wherever there was still a shadow, and there weren't many, we then used a cherry picker to physically measure those bits. And we produced a complete brand new set of drawings, not just a theoretical set, but an actual kind of as-built, which showed all the deformation. And you could have never done that just measuring it. It would be impossible. It was just incredible.
I used to do those sorts of surveys, not the digital scan version, the actual go out there and do engineering surveys. And it was best guess.
Yeah.
We could get the ends, we could get the corners, and we could pick a few points up. But when we were drawing it, we could have been miles out. We could have been putting in architectural windows or something like that, and where we would need to be 100% spot on, almost millimetre perfect.
We did a few Victorian brick railway tunnels in Manchester.
Yeah.
We scanned them in, we surveyed them, we knew the works needed to be done, but because there was no original as-built, that was our point. And then there was spray concrete fibre and all that. Then afterwards, re-scan tunnel, you know exactly how much layering is on there.
Yeah, exactly. That's exactly what we
Perfect
did.
for that.
Same thing.
Perfect.
Because it was a NATAM tunnel, you can't tell just by looking at it whether it's moved or not. It's impossible.
Right.
And then when we merged, after 6 months, we merged the two images, you could then see the differences. And there weren't any differences except where these jet fans were hanging down.
Yeah. So if you were doing that survey manually, what you'd probably use is a pole with a reflector on it, and you'd shove it up. And there's no guarantee that you'd put it on the same place every time. So scanning takes away all of the guesswork, all of the risk, and can very definitely inform a decision, an engineering decision based on that. So
Shocking, the results, shocking,
Indeed. It's incredible. I was blown away by emerging digital technology 10 years ago. And now, this is science fiction. This is bonkers. You saw the slides at the beginning. Were you all fooled? Did you honestly think I'd put that together and that was my presentation?
Yeah, we did. Why would we not?
Exactly. I'm going to ask you now, did you think that the AI one was better than mine? Certainly had more text.
It was all of excellent, Stan.
Thank you.
I think the other thing from the LiDAR scanning, certainly the bridge on the Hog's Back, is that what we couldn't have seen by observation only, or even going there and measuring it, was where the plates had slightly expanded by corrosion. We would have never, ever been able to spot that. And the computer and the LiDAR did spot that, and it showed us those anomalies. So we then knew which bolts needed attention, where the corrosion was.
Yeah.
Because you could, if you look at it, it looked the same. You never spot that.
You look at the simple stuff that we've had for many, many years as well. You take, for example, printers on site, all of our, I think 60 printers. That reorders also, that tells it when it has a fault. And we pay for our print network by page printed. And black and white is 2p and colour is 4 or 5p. That's been like that for as long as I remember. That's all done just automated as long as you've got an internet connection. So that's
Internet of Things.
all of this, what's next, isn't it?
Yeah, so that's potentially the Internet of Things. So it's connecting to the internet, and then that information is then being
We've had that for
used.
years.
Yeah, we have indeed, and that's a perfect example of what sort of things.
Service, yeah.
Yeah, the service industry is exactly perfect for it. Like I talk about the bin sensors. Absolutely perfect. Who do you want to? Do we?
Drones now, I work for Freewheelers, which is a volunteer blood bank. So
Yeah.
in the city areas, the droning, delivering blood, delivering critical medical supplies, drugs to people as well.
Okay, I'm going to tell you something that's going to beat that. So in Africa, I forget which country in Africa, but they're flying blood long distances to all the hospitals in the country via drone, and they shoot them up with catapults, and they'll drop the blood via a little parachute and then fly back to base where it's caught in a big net. I can't remember the details, what company it is, but that's incredible. That's hundreds of miles, and they can get blood to a destination. The furthest destination, it can be within 5 minutes, 10 minutes, 15 minutes. It can be 40 minutes, but it will get the blood there directly, and whatever blood they want in whatever quantities they want. So yeah, amazing what drones can do. Matt Atherton, sorry John, Matt Atherton's been waiting. Mr. Atherton, please.
Hello. Yeah. Just a quick one. First of all, congratulations on putting together a fantastic presentation.
Thank you.
A bit like watching a episode of the Discovery Channel for an hour. The amount of research that you've put into that and time and effort is very, very evident. Well done.
Thank you.
On Hinckley, I think, when we joined this project a long time ago, we were seeing quite a few, obviously because of the investment in the project and the money available, we've seen a lot of these bits of technology coming to the forefront, and we've seen that to continue through the project.
Yeah.
But of those digital advances that you've described during your presentation, which do you think we're going to see come on in leaps and bounds in a nuclear new build environment kind of in the next decade through your extensive research that you've done?
There's no easy answer to that one. I'm going to tell you that a lot of the document reviewing and checking, I would say, will be done by AI in the future, probably definitely within the next 10 years. Intelligent systems that can not only raw data, analyse large amounts of raw data, it can actually go in there and use the same thought processes in creative analysis to figure out what our lifetime quality records actually look like. So if you look at if we wanted to open up the chest of our digital twin in 100 years and look at all the lifetime quality records, a human being cannot go in there and do that. 10 human beings couldn't go in and do that. One AI, within a matter of minutes, could analyse the whole of that structure and start planning on how it can be analysed. So AI doing quality assurance and checking things, I think, is going to come on. So AI is going to explode. I would say in the next few years, but as you've seen from the demonstration, it's probably going to take over in the next few minutes. It's going to be the big thing. Scanning is the other thing. So what I see, so we've had Spot the Dog walkabout on the project. It's a bit namby-pamby. What I think is the improvement's going to go into aerial drones, and we won't have namby-pamby things. We'll have little drones whizzing around continuously. We could have several hundred little mini drones that are whizzing around taking LiDAR, point clouds, photographs, videos of everything, continuously recording. So continuous recording with aerial drones, I think, is the future. I think that's what we're going to see probably by the end of our project here. Other differences.
Augmented reality will be a key. Keeping the workforce informed.
Yes.
Building this for, but what is this for? On our projects at hospitals, we've had QR codes. and go up to that, you're building the X-ray part of this wing that's Osborne.
You've got it. And
Comms.
you've said augmented reality because that's the buzzword that you used to know. I told you a new one, which is mixed reality. And mixed reality is what we're going to get. And we've actually been trialling it on site. So we've got Kay's, I forget Kay's surname. Kay's is one of the field engineers, and we also have Dan Fraser-Pickard, who has been trialling mixed reality headsets to inspect rebar. Matt, that's something that's going to work out. At the moment, it's quite dangerous because it's distracting in a dangerous environment. But that's going to improve, that's going to get better. So probably before the end of the project, we'll see the mixed reality incorporated into what we do every day. There's going to be other things. Construction software is going to improve. Mobile tablets are going to improve to different wearable tech. But I'm going to leave it there because we could talk all day about what's coming. So does that answer your question for now, Matt?
I think you could have gone on for a couple of hours there, Scott. But
I could. I'm sorry. I could. I'm very passionate about digital technology and emerging digital technology, as you can see.
Brilliant to see.
Thank you.
There's perhaps an opening for an SME there, I think.
I don't think they'd pay enough, to be fair. Thanks. Yeah, probably. I don't think I would be the right person for it, but there are plenty of people on our site that know more about existing tech as opposed to future tech, I would say. So is there any other questions online, by the way? Oh, there's somebody in the chat. I'm sorry, everybody. I'm going to give John the thing back.
Something that was raised from Darren earlier, which we're.
Did we address that question, Darren? I don't think we did.
Zipline has 2 hubs in Rwanda to transport blood.
That's it. That's the one. Zipline. Thank you. Who said that? Alexandra. Thank you. Thank you. Darren's. Hi, John.
No, it's just his apologies.
Oh, right. Okay.
April.
Okay, to send the slide back out.
It's,
Okay, for some.
yes, there's nothing sensitive in this. There's nothing dangerous in this.
No.
All I would say is if I share it with you, please reference me. My name's already on there. Please don't take my name off of it. But I'm happy to share it with anybody. Is that cool?
Rather curiously, Scott, with when we LiDAR scanned that bridge 9 years ago on the Hog's Back, it allowed us to not only hire the guys and the girls who'd hot riveted with the 18th century technology HMS Warrior to go in there and pull the rivets out and repair them with an 18th century technology. So it's a curious juxtaposition.
Very, very, very good. Okay. Any questions online before we start? I'll move on to closing the meeting if there's any questions. Anybody?
No, not from me, thank you.
Thank you. Okay, it's quite a few people online. Just comments. Did you enjoy the CPD? Did it cover what you anticipated? Were you surprised with the first few slides? Nothing from me. Yeah, so how did you feel about the first slides? Any comments online about what AI generated and how I tricked you into thinking that was me?
Incredible.
If you can send me a link, that'd be great.
Oh,
Very useful.
it's to me, TOME.app.
AI bot, something like that.
There's plenty of them. Alex is sharing one as well there, which was
I think
AI.
it's AI bot, something like that.
AI bot.
If you just Google it, there's quite a few out there.
Exactly. Alex is saying, Google it. There's plenty out there. There is. I was surprised when I did it.
That's the one. ChatGPT.
Yeah, ChatGPT is another one. In the room, any questions? Can I finish? Oh, Mike's got a...
No question, just thank you very much. It's absolutely fascinating.
Yeah, thank you, Scott. Well done. Brilliant. Give me thanks for the usual way.
Right, okay. I'm going to put my chairman hat back on, even though I'm not the chairman anymore. I must point out. I'm going to thank Scott for his lecture there. Thank you very much. And Some applause going on there. Proposed forthcoming dates. Right, okay. We haven't done events. Summer socials coming up. That's not next month, the month after.
Do you have a date for that, please?
It's supposed to be the 4th Thursday, but it's normally an issue with bank holidays in August. So what we might do is we might drag it forward. Okay,
Yeah,
I can tell you the date of our Christmas social. That will be on the 14th of December. Okay, this summer social, I need to find out what's happening around working weekends and whatnot. So,
If you go for the 17th, I'm just suggesting the 17th.
why are you suggesting the 17th?
It's not here.
We'll give it that.
Oh, hang on. If you're talking about August, not December.
August, yeah, so it's around about the 17th or 8th. I think it was 18th we had last.
Yeah. So the problem is that fell on a non-working weekend, and there was nobody here, if you remember. So we had to move it. And last year we moved it. So what we'll do is we'll do a little analysis on that.
17th of August, question mark.
17th of August, question mark. If it's on a non-working weekend, we'll move it left or right to suit. It could even come out of August if it has to go into July or September. As long as we get it in and around there, that'll be fine. There's any other business? This is regarding nuclear chapter meeting. Any other business? Because I've got something I'm going to raise if nobody else does. Speak now, forever hold your peace.
Was there any movement on the HPA business?
No movement whatsoever. Right. Not movement. And the reason being is I've been too busy and I haven't been able to reach out to Tom Barnett. I must make a point of reaching out to Tom Barnett and get that sorted out. Is he still online?
You on there, Tom?
Tomo? Can't read that. That's it. God bless you. It's probably got no meeting.
Looks like it's left.
Maria's wrote, this is the first meeting I've attended. I have found it very interesting. The presentation was great. AI was surprising on the presentation. Thank you for that comment, Maria. I'm glad that you've enjoyed yourself, and you're welcome to come along anytime. You don't need to be a member to come and spend the evening with us. So thanks for that comment. There's another comment.
I'll read it, John.
Thank you, John.
So from Paul Sampson, regarding AI presentation, thank you. Thankfully, you redeemed yourself from what would have been a mundane presentation, reading off a presentation verbatim that has that effect, I think. Otherwise, a very interesting other presentation. Thank you.
Thank you, Paul Sampson. Paul, this is the first of these meetings. Paul's one of the QMLs on site, and he's currently doing the quality management control professional practice course. He's one of our delegates. So welcome, Paul. Okay. I'm just going to say, any other business?
Anybody can try and come in. When you're walking around the site, you might see 3 big black trailers with a cover over them.
Yeah.
They are big video screens, basically. So 3.5 by 2 meters high, hydraulically go up in the air, turn around, fully IP rated with speakers on them, and we can control and send message to them remotely as well to inform the workforce.
Oh. So it's outside screens.
Outside screens on trailers. You know, like football stadiums, we just bought bylaw to communicate to our workforce. So the ramp by the west, the east as you come up for the bus, and the north as you go down by the old pump station there.
Well, you heard it here first, everybody.
So we're going to try and we've got an app now to inform our workforce for everyone in bylaw, and that's the next part of our comms as well. So probably linked to a bit of technology now. We're going to try to inform people via screen.
I like it. I like it. More emergent digital technology. Thank you very much.
It might be taking away phones from certain areas. So
we've been told January the 1st, no phones on site.
Right.
We're warming up for that now.
Okay. Did you say January?
And hence why you've got screens.
Did you say January? Yeah.
January, yeah. DBF informed us. No phones on site. In an office, but not your place.
Okay.
Physical work.
Okay.
Calling each other by tablets.
I don't know how we're going to function like that. Anyway, that's not for us to discuss here. Okay. We've covered any other business.
Scott, if we just get more, remember, if you come here, we can feed you.
Oh, yes.
Oh, in person.
You will not believe the spread we had in the Brazos tonight. It was amazing. We've got pictures and we'll share them, won't we, John?
We will.
Yes, we will. And when you see these pictures, you're going to be flabbergasted. I have never seen. This is better than our Christmas buffet last year.
It's awesome.
It was good, wasn't it?
Even Heston come out to say about
Oh, okay. So, because of the time, I'm going to express my last duty as chair is to award 2 hours of CPD for tonight. Thank you very much for everybody that attended. Upcoming dates are next month is the 22nd of June is meeting number 31 and July is the 27th. And the summer social, of course, is in August. Dates to be confirmed. I'm going to ask Mike now. Mike, have you got anything lined up for us CPD
I've got a
wise?
couple of people that just need to confirm.
Ooh.
One of them will definitely be able to do it.
See, that's always good. Get two lined up.
Yeah.
Get two lined up. That's the way to do it. One falls out, you've got the other. I'm intrigued to find out. I'm sure you'll let John know in due
The
course.
ugly people will be one of them, and the other one is the guys who did the Carolina thing couldn't make it.
Oh, I know a little bit about the Carolina mitigation package.
We were there, weren't we?
Yeah. Right, okay. Thank you everyone online for coming. Thank you for those of you that come for the first time. You're here for the first time and I'm chairman for the last time. If we don't have anybody to chair next week, I'll be doing it again by the looks of it. But till we get a replacement, I'll be hosting things and helping John and Matt continue with this wonderful chapter. I believe I've taken it almost as far as I could. I could stay here forever because I have such a wonderful time working with the officers. The senior officers and the junior officers, for me, it's like standing on the shoulders of giants because my job is made so much easier by the dedication and support of my team that is no longer my team, and it's sad. It's sad to say. So it's joyous that I'm being made up to a member of the management board, and it's a shame that I have to step down as chairman of this chapter. Thank you very much. That's my final word. I draw the meeting to a close. Thank you very much.
Thanks all. Cheers, Scott.
Thank you. Bye all.
Thank you very much. Bye-bye.
Thank you very much. Bye.
Okay,
I was still doing it.
stop recording, please, John.
Before we got some replacements, but
Yes, Scott.
it took a year.